First today, it's my great pleasure to introduce Craig McLuckie, VP of R&D here at VMware. Craig is the co-founder of Kubernetes, and today he's discussing the evolution of operations with the help of some very special guests, Bosky Savla and Grant Shipley. So you'll want to go full screen for all of the demos today. They're all really good. They're definitely worth it. So let's cross over to Craig.
Hi, folks. My name is Craig McLuckie, and I'm extremely excited to have an opportunity to speak to you today. During yesterday's keynote, we heard how Spring is fundamentally transforming Java development for enterprises, how the work that we're doing in this community is emerging as a staple for enterprise Java development. Today, I'd like to take a little bit of a different tack and talk about the evolution of operations. When you look at the industry as a whole, there's been this really exciting trend that we've seen starting to take hold over the last years. And it's really an evolution about how work is done inside organizations. If you look back historically, the primary unit of work when developers were interfacing with centralized IT teams or operation teams was the ticket. So the world was ticket-driven. And increasingly, with the advent of cloud technologies and more practical infrastructure abstractions, we're starting to see this move where the atom of work, the unit of work that developers can rely on, is the API. And obviously, there's a burgeoning set of technologies that bring these two worlds together, that pragmatically match what developers are trying to accomplish from an outcomes perspective with a way to drive the infrastructure into the desired shape to support those outcomes. And this really represents an interesting fusion of the worlds, the developer platform worlds, but increasingly the infrastructure worlds as well. And if you've been an attendee of SpringOne for some time, you will have seen a number of customers stand up on the main stage, obviously a physical stage rather than a digital stage, and talk through some of those experiences. And when you look at the experiences of all these customers, one thing stands out. They've been able to use the power of Spring and developer framework technologies that have been driven into an infrastructure environment by intelligent systems like the PaaS system, what's now called the Tanzu Application Service System. And as we look to the future, we anticipate that this will continue. And when you look at the core of this whole outcome, like what's driving these experiences from a developer's perspective, it's really about being able to create a superhighway from the developer's IDE into a production environment, enabling developers to have a fully curated set of dependencies, tools, everything they need to be able to produce the business outcomes. And it's really interesting. When I spend time with organizations out there in the wide world that are at varying points in their IT journey, it's always interesting to ask the question, how much of your time do developers spend actually developing that is capturing business logic and code and solving real problems that are advancing your business versus engineering? That is the amount of time they spend setting up the environments, whether that's pre-production or their own local development environments or the production environments, worrying about how to set up continuous integration and delivery tasks, sweating the details about how their code ends up in a production context. And for most organizations, it's unfortunately disproportionately weighted towards that engineering factor. And the work we're looking to do here is to change that, really enabling developers to focus on the thing that is driving the business forwards. And the root of that, from our perspective, has always been the CF push experience. How do we create that superhighway? To be able to accomplish this outcome, not just for the set of applications that fit well into the 12-factor patterns that developers have been using, but to think about it more generically, we need to ensure that we're supported not only by a set of agile practices, but that those practices are supported by agile infrastructure primitives and the technology that's able to make the best use of them. Now, if you look back at my sort of experience, I've obviously been a huge fan and advocate for Kubernetes. Kubernetes is a technology that effectively abstracts away the infrastructure, allows a variety of different infrastructure environments to look and feel consistent, and solves the problems of living with an application in a production context. But it's always had challenges from the experiential perspective. How do we bring that really clean experience into that environment? And I've been so excited to be a part, a very small part, of working on bringing that CF push experience into the Kubernetes ecosystem. And what I'd like to do is just peek under the covers a little bit and articulate what exactly is happening here. Why is this so exciting? And I think that if you look at technologies like Kubernetes, it's become not only a destination for building and running distributed applications, but it's also become an environment in which we're seeing a tremendous amount of additional innovation. We're starting to see the emergence of service mesh technologies. We're starting to see the emergence of a lot of other adjacencies that support these outcomes. And what we're working to do with the work through the Cloud Foundry ecosystem, with the initial beta of the Cloud Foundry experience on Kubernetes, is really bringing these worlds together into an incredibly coherent and valuable form factor. So now let's look at what this feels like, what this looks like, and what you can expect from the bringing together of these two technologies. And I'd like to hand off to Bosky, who will walk you through that.
Thank you, Craig. And now we are going to take a Spring Boot application that uses Spring Data Services and see how Cloud Foundry is going to help us deploy that application into Kubernetes. Now, because Cloud Foundry is working with Kubernetes, it is going to simplify the overall developer experience by automating a lot of the tasks that a developer has to go through in order to deploy an application into Kubernetes. Let's take a look. Now, to begin with, I have Tanzu application service for Kubernetes deployed on a Kubernetes cluster. This is the dashboard of that K8s cluster. I'm using Octane to visualize all my objects here. So you'll see the cluster has 5 nodes right now, and it also has some persistent volume. And it also has Cloud Foundry components installed. So you'll see namespaces like CF system, CF workloads, etc. And these namespaces essentially hold the Cloud Foundry component pods and containers within those namespaces. So the CF system namespace is going to hold all the Cloud Foundry components. And then once we start pushing our applications for this Kubernetes cluster, you'll see them rolling up into the CF workloads namespace. So let's take a look at the CF system namespace. And you'll see that this particular namespace has all the CF API server, Arini, Fluentd, etc. running on it. And this will be the API that we talk to using the CF CLI. Now let's take a look at an application that we want to push through this Kubernetes cluster. So for this demo, I'm going to use Pet Clinic, which is a Spring Boot-based app that needs some services and dependencies. We already declared that in our pom.xml file. Particularly, it needs a SQL service to store data into. And once we have, I've declared that dependencies, I've also created a manifest file, which basically tells Cloud Foundry what name to use and where is my executable tar file for it to package up. Over here, I've already installed my CF CLI, and I am pointing it to the CF API that's deployed within that Kubernetes cluster. And I'm already targeting a particular org and space within that Cloud Foundry environment. Now, to deploy this application, all I have to do is just push the app. So I'm going to do CF push. Now, in the backend, what's happening is Cloud Foundry is going to package up this jar file and all the dependencies it needs, create an OCI compliant image for us, and store that image in a registry, and then deploy that application as a pod within the CF workloads namespace. Right now, the Pacato build packs, the Java build packs are going to build that app for us. Right, so the application has been deployed, and what I want to do now is create a SQL service and bind this application to that service. So I'm just going to create a MySQL database service using a service broker that's installed on that Kubernetes cluster. Now this will take probably a minute or two. What's happening in the backend is that Kubernetes cluster is going to create a persistent volume claim for this particular database service, and then bind that to a pod that will be running, that will be accessing that particular persistent volume claim. let's make sure that the service is up and running. So I'm going to just do CF service, pet clinic. It's created the service, and now I simply bind my application to this particular service. So I do a CF bind service. All right, and now if I restage my application, it will start using or consuming that SQL service. Right. So while it's doing that, I want to take a look at Kubernetes Cluster and see what's going on in there. Now let's take a look at that MySQL service. So I'm going to buy service broker namespace, and you'll see that there's a MySQL pod created. And this particular pod has some secrets, deployments, and persistent volumes created for that. So let's take a look at the persistent volume claims. You'll see that this particular pod is using the particular PVC that was automatically created. In this case, cluster by CF CLI. And you'll see that this particular pod has the persistent volume claim automatically attached to it for our MySQL database. Now, if we go back to our CF workloads area, and look at the pods that are deployed over here, you'll see that now there's a pet clinic pod running with 2 container images. One container is actually the application itself that is packaged up, the jar file, and then the other container is basically the ingress or the Envoy sidecar so that we can route traffic to it. And notice the CF or the Cloud Foundry actually automatically created the stateful set, a secret, etc. for this particular pod, so it understands how to talk to the SQL service. So now let's take a look at the application and the route that it got. So this is the ingress route that it has, and I'm going to go ahead and hit that on my browser. You'll see that this application is running, and we can get to it from our browser. So in summary, if I had to deploy this particular application directly to Kubernetes, I would have to write my application code. Apart from that, I would have to create container images, create a Docker file, build those images, tag them, push them onto my registry. And then once I have everything, I would have to actually make sure I have the corresponding Kubernetes YAML file created, for example, for the deployment type, for the service type, for the secrets, the config maps, etc. I would have to similarly do the same thing for my database pod that that particular app is going to talk to, and make sure that it ties to that particular application, and then finally deploy all of this into Kubernetes. Instead, if with Cloud Foundry running on top of Kubernetes, what I have done instead is created the app, did a CF push into that particular Kubernetes cluster, created a service using CF create service, and then tied that or bind that service to that particular app. And all of the backend operations of creating config maps, secrets, persistent volume claims, etc., all the necessary Kubernetes objects and YAML files have automatically been handled by Cloud Foundry. Thank you for watching this, and make sure you check out all the Task for K8 sessions.
Thank you, Bosky. Now, as you can see, what we've worked to do with the CF community is to bring that superhighway experience into a production environment. But one of the challenges that exist out there in the industry, and this has existed for a long time, is that while those high-level abstractions create tremendous amounts of opportunities to optimize the development experience, you always encounter these experiential cliffs. There's always something that doesn't fit naturally into those frameworks. And so as we think to the future of innovation in this area, something that we're really invested in is raising the watermark, providing a set of modular and composable pieces that can be pulled together to deliver those experiences for a much broader array of workloads. And what I like to say is, you always want to use the highest abstraction first. As a IT team making decisions, or as a line of business team making decisions around which technologies to use, encouraging developers to use those higher level abstractions first makes a tremendous amount of sense. But there's a lot of work that we still need to do as a community to make those experiences applicable to much wider array of workloads, to enable within verticals, within specific industries, the ability to pull that together to create a coherent experience. And so when I look at Tanzu, the mission behind the work we're doing here is to foster innovation and make that innovation accessible to developers everywhere. That really provides the glue that ties together those experiences, that enables you to create that platform experience that's tailored to the specific workload that you need to deal with on a day-to-day basis. And with that in mind, I'm incredibly excited to introduce the VMware Tanzu Build service as a new offering that is now generally available. And the vision behind that is to distill out capabilities that Taz has offered historically to securely construct a packaged Spring application and make it accessible for deployment into a wide array of contexts. This is a challenge that industry has had for some time, something that I believe that Taz has done uniquely well. And our intent behind this is to modularize it, make it accessible so that it can be used by itself, to genericize the capability so that you can fit it into other factors, and ultimately democratize it so more developers can use these powerful capabilities to bring their Spring applications into a production environment. And so ultimately, we see Tanzu as glue. It's pulling this all together. And when I look to the future, it's really interesting to see where this might go. And a great example of this is the ability to construct functions. Meaning, if you want to run a small amount of code at the other end of an event, you should have that ability. And that should be a natural part of your tool chest as a developer. And when we start thinking about Spring and Graal VMs, and some of the innovation that's happening in Kubernetes and in Kubernetes adjacent efforts like Knative, we're now able to bring this all together in a coherent way. And I'm excited to introduce Grant, who will be talking you through what this experience looks like.
Thanks, Craig. I'm super excited to be here today to show some of the great work we've been doing over at VMware in relation to Kubernetes and making it accessible to Spring developers. To showcase this, I'm going to be running through a demo scenario showing a path to production. And we're going to be leveraging the work that Sebastian and team did that you saw in a previous demo to take a natively compiled Spring Boot executable and running it all the way through a CI/CD pipeline and deployed into the native Kubernetes cluster. Let's get started. Let's start our demo journey using Tanzu Mission Control. Tanzu Mission Control is a software as a service offering provided by VMware that will allow you to create and manage Kubernetes clusters. Let's go ahead and create a cluster for our development demo today. To do that, you click on Clusters and then Create Cluster. I'm going to be deploying this to AWS, and I'm going to give it a name of Spring Development. You can also select a cluster group for this to be a member of. This helps with organization and applying policies. I'm going to click on Next, and I can select the region that I want this cluster to be deployed to in AWS. And then I can select the control plane type that I want deployed with my cluster. You have the option of deploying a single node control plane, which is great for development. And you have the option of a highly available control plane, which is what you'd want to use for production. You can also select the machine sizes. I'm going to go ahead and click on Next, and then you can specify the number of worker nodes. This is the number of nodes that will actually hold your applications. After you do that, you simply click on Create Cluster, and Tanzu Mission Control will go off and do all the work to deploy this Tanzu Kubernetes Grid cluster for you. Now, it takes about 10 to 15 minutes for this process to complete. So for the interest of time, let's fast forward to when this cluster is actually completed. While the cluster was creating, I went ahead and I git cloned the famous Pet Clinic Spring Boot application to my local machine and opened it up in my IDE, Visual Studio Code. Let's go ahead and change a couple things. The first one will be the messages.property. Let's just say welcome to SpringOne. And let's also change a class file. And we'll just system.out.println hello from the controller. And we'll save those changes. So now that we have made all of the changes to our application, and we're not embarrassed by our code, we should probably go ahead and commit it up to the Git repository to let our CI/CD system pick it up and deploy it into a different namespace in Kubernetes. One of the great things about this CI/CD pipeline that we're getting ready to execute is that it takes advantage of all of the work Sebastian did and showed you in a previous demo, and that it's going to build a container image and it's going to compile this pet clinic application using GraalVM. And this is going to provide us a lot of features, such as a low memory footprint and lightning fast startup times. So the way we trigger this pipeline is actually via a pull request. We can see that we have two changes here. So I'm going to check these changes out to a branch, and we're going to call this SpringOne demo branch. And then I'm going to commit these two changed files that we've made as part of this demo. And I'll just say update, and it's going to ask me if I want to stage my changes. I'll say yes. And so then we want to push this up to our Git repository. So let's go ahead and select push. And then we want to publish this branch. And so now we will quickly pop over to our Firefox web browser, go to our GitHub repo. In this case, it's github.com/Shipley SpringOne. And we should see that a branch has recent pushes. So let's go ahead and create a pull request for this. And so this would be if you're doing a code review and you want to see the code running. What's great about this pipeline is that as soon as I create this pull request, it's going to trigger the pipeline event. And this will run through the CI/CD process and deploy the changes made in this pull request inside of a container so that my team or other people could look at the changes. So let's go ahead and create this pull request. And then let's open up the Tecton dashboard that was deployed as part of our Kubernetes cluster. And you can see that we have a pet clinic native pipeline run happening. And this is going to run through and build the code. And at the end of this, we're going to have a new namespace created, and it's going to be running the GraalVM compiled version of the pet clinic application to allow others on my team to check out those changes. So let's go ahead and let this build process run. As you probably learned in Sebastian's demo, it does take a bit longer to build down to a native application using Spring Boot. One of the great things about this pipeline is when it completes, we've also added a trigger in that it will update the GitHub conversation for this pull request with the URI to look at the changes as it's deployed inside of a container on Kubernetes. Now, also, we're taking advantage of Knative serverless and scale to zero functionality inside of this pipeline. So what that means is we're taking advantage of all of the GraalVM benefits that we get, like low memory footprint and lightning fast startup time, to deploy this as a scale to zero. And so let's illustrate this using Octant, which is the dashboard for developers. So if I look at this namespace, we only have one pod running right now, and that's the MySQL database. Now, keep in mind, the pipeline also deployed this MySQL database and configured all of the database information, such as username, password, things like that, in order to connect to it. So let's go back to our GitHub and let's copy this URI, and let's showcase this by moving this to a split screen scenario. So I am going to paste that URI in, and what you'll notice as soon as I hit enter, the scale to zero with Knative will take effect, and it'll actually scale that container up, and you can see how fast the startup time is for this and how fast its service requests. All right, I'm going to hit enter in 3, 2, 1. I just hit it. We can see that the container is spinning up and it's already serviced that request. Look at that startup time and the ability to service these requests in a scale to zero fashion. It is truly game changing in that we can use Spring Boot for serverless functions and other scale to zero scenarios now. So let's bring this all together at the end with an added feature that was deployed on top of our cluster as we deployed from Tanzu Mission Control. And that is the ability to add observability to your applications and to your cluster. And we do that via Wavefront and Tanzu Observability. So let's go ahead and close down the Octant dashboard and go to the Wavefront dashboard inside of Firefox. and I'm going to select to view the Kubernetes dashboard. And let's select our cluster. And we can see that we have 3 nodes running. And then we can drill down into specific namespaces. So let's look at that scale to 0 deployment that we just created. And we can see that we have the actual pet clinic deployment running right now. And then we also have the MySQL database. And so if we click on that database, we can get information such as CPU usage, memory page faults, things like that. Just a plethora of information available to us. What's also critical is the application observability that's built into the platform. So if I go to application status, we can see that we have Pet Clinic. So let's click on that and let's look at the traces. And so I can dive right in and start to get some observability onto the application that we've deployed. So that wraps up our demo journey, where we went from an integrated development environment using Kubernetes all the way to a path to production using CI/CD pipelines, taking advantage of Graal VM and Tanzu Mission Control. Thank you. Thanks, everyone, for your time, and I'll turn it back over to Craig.
Thanks, Grant. Now, the future is bright. I'm extremely excited to have this opportunity to bring the world of infrastructure technologies and participate in stitching that together with incredibly powerful and relevant technologies like Spring. And I think if we look to the future, this is going to create tremendously differentiated outcomes for our customers and for enterprises as a whole. It's going to mean that we have much more determinism in terms of how applications are being built and delivered into production contexts. It means that as we bring these technologies online, the role of the operator is going to evolve so that they're able to deliver a set of services rather than having to serve tickets on a day-to-day basis. And ultimately, I see the fusion of these environments of the world of developer platforms and the world of these polyglot technologies like Kubernetes or Knative as driving the next wave of innovation for IT. And what I believe the outcome of this will be is ultimately the ability to think of development as participating in a secure software supply chain, having developers empowered with tools that they know and love, that they're able to use on a day-to-day basis, but resting assured that they're supported by technologies that ensure that that delivery is safe and secure, and enabling them to really focus their day-to-day life on capturing that business logic in code, rather than having to worry about the details of how that code is getting into production context and the mechanics of operating that on a day-to-day basis. To continue this conversation, I'd invite you to attend some really exciting breakout sessions that are coming up. Stefan and Brian are doing a session on Spring Boot Loves Kubernetes. Ben Hale is doing a talk on Spring to Image that is well worth catching. And Deepa and Ramiro will be talking about Tanzu Service Mesh from the developer's perspective. I think all of these sessions are relevant to the conversation we just had, and I'm definitely excited to continue this journey with everyone here. Thank you so much for your time.